Hey, hello there. Welcome to SkyTour LiveStream West. As you can see, we have a moon tonight, and we're working around that. But we are sitting here. I have Daryl with me. How you doing, Daryl?
I'm good, Mark. How are you? Hello, everybody.
Yeah, hi, everybody. We have some light high clouds, and they do tend to get in the way. So apologize for those, because, of course, it's all my fault that they're there. I figured it's just gone too long without a stream. We have to do it. And right now, I have the gain down lower. And gain is what we use to adjust the sensitivity of the circuit. And it's taking exposures you can see here. This is camera control and the acquisition control, so to speak. And right now we're doing 10 millisecond shots. And the gain is, I'm going to bring it up higher, and you'll see that we're going to see more noisy stuff in there. But the cloud's pretty thick there, so I'm going to actually increase this exposure time a little bit. Let's go back to our 1 second. Just trying to, the point of showing it to you is just to give you an idea how the moon actually looks in the sky here. But we do have some clouds up there that we're just waiting to have drift by and get out of the way, and then we will be ready to move along. I also have the focusing system up over here, which Daryl and I were just using a few minutes ago. And we will be using it again shortly if we get our clear sky back. Okay, 1 second. Camera controls come out. The 1 second shots. The gain is like the ISO on a camera. So 350 is pretty reasonably high gain for this dedicated astronomy camera. And the exposure is 1,000 milliseconds because there's 1,000 of those in 1 second, so it's a 1 second exposure. All right, and
You compare the gain to ISO.
Yeah.
Like a gain of 350, though, that doesn't equate to a film speed of 350, though, does it?
No, it does not.
Yeah.
No, it's just
Don't mind me.
No, that's actually a very good point. Hi, Marianne. Hi, Bonnie on 177. Mike C, what's going on? Hi, Pete Bods is here. PG, hey, good to see you. Going to see you in just a couple of weeks now, up in Pine Bush. And Renee Cruz, I saw earlier here. Danny Daring, what's going on? Thanks for joining us. We're just waiting for the moon to come back. You can see I have 1 second exposure, so the moon is being revealed. It's like we're just, pulling the shade off the moon. You can see it there. I'm going to drop us back down to a 10 millisecond shot here, so we can actually see it without overexposing it. So all of a sudden you'll see the moon. There it is. Okay, and got to drop the gain down. Bring it up just enough so you can see the clouds moving across. It's pretty eerie out there right now, but like I said, it'll be good. We'll see it in a minute. It'll be coming up. Yeah, these clouds are temporary, I'm hoping, so we'll be able to actually see some things. With the moon out, it's best to look at nebulae that are red. Because the moon puts a blue cast in the sky, so blue nebulae kind of get lost. But I have a few I want to show you, and it's actually they're right above the moon. It'll be kind of a good test. The Lagoon Nebula, Trifid Nebula. Hopefully we'll get to see those. So here's what's going on. I don't know if you guys got a chance to see the show on Discovery Plus called Alien Invasion. I did that show with Ben Hansen and Melissa Tittle, and we were investigating the Hudson Valley UFOs over the course of like literally 100 years. And the show actually came out pretty good. I was surprised, because usually these shows are kind of like rehashes, but this is new stuff that no one's actually, talked about before, because some of the people we talked to never talked about their experiences. So it was neat, and we actually drew conclusions. So check it out if you can. Oh, you did see it, Leslie Latin Taylor. Great, thank you. I'm glad that you liked it. Yeah, there's a Nova, but I don't know if we're going to be able to see it.
Supposedly naked eye.
Yeah, but I don't know if we can see it tonight.
I understand.
Yeah. Hi, Timothy. And of course, I said hi to you before, Marianne. Nice to see you. Oh, Pete, don't be sorry to ask. Asking about the supernovas is very cool, If we can see these things, we're going to go see them. Let me see what's going on here. Other thing, too, is I can bring up another view to show me what's going on. What is that doing? That dumb thing. I hate when that does that. Oh. Why, oh why? Yeah, we got a lot of high clouds up there. There weren't supposed to be high clouds. I did not order these. Wow. Didn't order these clouds.
Look, you got some bugs flying around too.
I do. Yeah, I do. Alright, let's go and... Okay, well, I'll just show you what we're looking at here, guys. This is where the telescope is located, and this is the satellite map. Okay, and in the visible, you see some clouds, right? And that's not actually the exact location, by the way, just so you know. It is protected property, so we don't have that information out, but it is in this general vicinity. So that said, this will tell us something. This is a live infrared cam, so we can actually move it around and see what's going on up there. Yeah, I gotta... Yeah, these high clouds are not there before. Is not always the case.
New telescope syndrome or new observatory syndrome.
Yeah, I think you're right. I mean, they're
It
everywhere.
may be cloudy for years.
It was totally clear out there just before we started. What is on the radar and the weather radar that we're looking at? The visual. Sometimes the lighter clouds don't show up at all, but you can see that they're up there. So we'll just hang out with it a few more minutes, see what we can do. I hate for this to be a bust tonight, but hey, you know what? This has happened before, and we have been okay, right? Let's do 40 milliseconds. I'm going to ask you guys something too. Do you think that if I were to start a stream at 3 a.m. Eastern Time, would that put everybody unable to view, all of you guys, or would you find that you're willing to do that, or some of you are up around that time? Because if you are, then what I might do is just go to bed early and get up at 2 o'clock and be ready to stream from 3 o'clock until dawn. Because I've noticed that the early morning out there is literally totally clear. most of the nights. Now, the reason it's not clear is because it's the monsoon season. So that means that there's plenty of rain that's in the area. So when you talk about this in this regard, oh, thank you, Leslie. When you talk about this in that regard, oh gosh, the moon is so eerie. It's like you want to howl. The nights are going to have some clouds in them, but the truth is that the sky out there is probably the best sky one could hope for. You know. Oh, look at that! You can see some really cool crater definition there. Let's go into waxing gibbous. That's right near. That's right on the face of Mare Imbrium. Yeah. So yeah. DK, welcome back. Yeah, I've been, we've been on, and nicely. The fact is that now that we're doing this, we've actually got a wonderful telescope system, and everything is just going really nice. So it's actually hard to take a picture of the moon because it's really bright, and the camera is a dedicated low light astronomy camera. But I can. I mean, I've got the gain way up. If I tone it down, then the moon will almost disappear. But it looks a little more normal, see? And then over here, while we're waiting, might as well. Over here, you see this is the telescope. This is me down here. Hi, that's the telescope. That's the peak inside the dome. Telescope control program that you're familiar with. Okay, this allows me to access the telescope computer. This gives me the north, south, east, and west. And I have a new piece down here. This here is the actual handset of the telescope, and when you look at it, basically this handset of the telescope, thanks to Tara Diulis, she actually went out and put this in for me. It allows me to see what the telescope thinks is going on its handset. Very, very important data. Because you cannot get that electronically. Hey, look, we got some clearness here. Look at this. Look at how beautiful those clouds look. That's really pretty. So now, if I actually bring down this exposure some, we can actually get down to where we'll see the moon like we should see it. Oh, look at that. Okay, this is the if this is the frame, this is the actual size of the moon on the frame of this particular camera, okay? This is the frame of the camera, square here. It's literally just, it's over 2 degrees wide, 2 degrees, 2.5, and then 1.5 degrees tall, all right? So the moon being 30 minutes of arc, that's half a degree. So if you were to take one, a second moon might fit right about there, and it looks like just about a third won't fit here, but it's a little bit less in practice. But then this across the front here, you've got about 2.5 degrees. So the full moon, remember, continues this way, right? So we look at this way as the full moon, and if we were to turn that on its side and measure, we would find that we could put a whole bunch of moons across the front here, right? So we're talking about 5 moons or so, which is kind of cool.
And 2 degrees?
2.5, actually.
Oh, 2.5, okay.
Yeah.
Yeah, you could comfortably fit Earth east to west across. You'd cut off the top and the bottom of it, but...
yeah.
Yeah.
If we were on the moon, you mean?
Yes.
Yeah. That's right. Yeah. So this is really pretty. I mean, I'm liking, what this looks like now, and I'm actually going to go check out the sky, and we can look at the sky actually. And those little dots you see flying around, those are actually bugs and stuff. I know they look like meteors, but they're bugs. Meteors don't curve. Okay, so we actually have some we have a lot of bugs out there. Bought the low light security camera out on the grounds is able to pick up all the things out there. And it can also see the sky. You can see the stars, not as clear as you'd like, but you can see them. Alright, well, that's pretty cool. So, what I have now, I added new technology to this. Hey there, Daisy and Zoe, how are you? The new technology is that I can now, wherever the telescope's pointing, I can hit a button and I can do something called a plate solve. What that means, it's a fancy term for finding out exactly, and I mean exactly, where the center of the frame is pointing in the sky. That's really important, because if we know exactly where the center of the frame is pointing in the sky, then we can actually do real research, because now we have the ability, say, if we find an asteroid, we can track it and get its exact position in the sky. If we see something that looks odd, we can actually get the exact position of it without guessing, and that's something else that's really important. So there's a lot of that new tech has changed a lot of stuff for us, and it's really, really cool, you know. So if anyone has any questions, please feel free. It's good to see you guys out here. You're the night owls. It's actually, some of you are the early owls if you're overseas, or no, if you're well, let's see, the early owls are the people that will be maybe all the way out in Australia. I think Australia. I think I don't remember what time it is in Sydney right now. They're what, 16, 14 hours ahead. I'm not sure. I forget.
Roughly, 5 in the morning in England now, or the UK, and
yeah, the early birds would be overseas there. You know,
I guess Europe would be more like 7, 8 hours.
yeah,
8 hours.
Yeah, they'd be in the middle of their day.
6 a.m. or something like that.
Yeah.
If Isabel was here, she could tell us.
Isabella, yeah. I think they're 9 hours to Sofia, Bulgaria. I could be wrong. If we go to 100% size, okay, give you an idea, the camera still needs to be focused, but actually now that the moon is out there, the clouds are out there, I'm going to try and focus. This focusing system is extremely, extremely accurate. If you notice, it's 49,632. That's how many steps I'm at currently in the camera. And to get this focused, you're going to actually be going through maybe only changing these lower numbers here. These numbers, you change them, it's going to be blurry as heck. You know? But, and there's also a problem with the telescope that has to be remedied when I get out there. And that is that the lens that is on the end that replaced the secondary mirror is a lens that is not aligned properly with the main mirror of the telescope. So I have to do that. That's called collimation. And it's not collimated right now, and I'm going to do the collimation when I get out there. Yep. And I do have there's a focus assistant I could use to actually focus this. But I need a little bit more practice with that particular program. But it's kind of cool, though. We can try it. Focus assistant. And we'll do... Okay. Now.
Would it do better on an autofocus with a point source?
Maybe. I mean, there is a semblance of an autofocus on this. But I tried it, and what it thought was focused was not. So you have to collimate it first, you know. You really got to get it collimated.
Yeah.
You know. So the idea is you're trying to get the number down to the lowest. Oh, see more clouds. And these numbers have to come down low. Okay. And as you can see, that number went up a little bit. And we had some clouds there. That's focusing. I'm bringing it in now, focusing in. And I'm trying to get it. Alright. I prefer to focus on stars, actually.
Yeah.
You know, but, you know, because I can actually just like zing this, you know, I can send it to like this really far place, and then you'll see that the moon on the right side isn't really focused. Okay, and then if I go even further, you'll see it's way out of focus. So that I can bring it into focus. It's like, you know, moving the eyepiece. I'm sorry, moving the focus knob. But because it's not collimated, we have to focus for the center of the field. And the center of the field, I need to just brighten up a little bit. And I am going to try and focus on a star if I can. Let's get up here. A little too bright. Alright, let's try that. Okay. Alrighty. You know what I just think is the coolest thing, though? Is I'm doing this from 2,500 miles away. That just freaks me out. I just still haven't accepted it. It's just the coolest thing. Hey, Sandy.
Living in the future.
I know. Damn it, we're going to invent the future. Using a remote observatory with a bunch of people from all over the world watching. I mean, that is cool. That is a really cool thing to do. You know? I love it. You know? Okay.
I saw a short clip recently on YouTube, I think it was, of some astronomy village kind of set up. Is up in the mountains of California someplace.
Okay.
And it came across almost like a real estate ad, the way they were pitching this thing, but
Okay.
Good grief. It was quite the setup. A lot of big buildings with big telescopes in them, and there were a lot of smaller individual setups, you know, they looked like dog houses with
Wow.
roofs on rails, and
Yeah.
individuals with their telescopes there. And they said they even had staff on site for telescope repair and stuff like that.
What's the name of the place?
I forget. It was a couple of weeks ago. I should have mentioned it to you or sent it to you.
Yeah, that's where people go, probably rent telescopes, you know.
That too, yes. I mean, there was a ton of them there. Several big buildings and then a whole bunch of smaller doghouse observatories.
Sure. Okay, I'm going to go to 49,917, which is where the telescope said it was focused on stars before, so now I'm going to tell it to go to that. So now the telescope's focusing setup has gone to that. This is what it thought was focused for the stars. So we're going to go back out to auto, and it's going to set us to the full size. And I'm going to get rid of the focus assistant for now. And I'm going to move off the moon. I'm going to move to, let's find out. Well, actually, we can move to something we know, because I can just take us there by going to Stellarium. And Stellarium tells us where our telescope is pointing right now. And let's go to, let's zoom in a little bit. And let's let's move just west of the moon here. Now east of the moon. All right. So we go back here. I'm gonna take the focus off for now. All right, and we're gonna go east. Yay, there goes the moon. Slipped out of view. All right. And if you look in the little window, you can see the telescope is subtly turning to the east, which is to the right, as seen in this view down here. And that one right there. Telescope's moving that way. Okay. All right. So let's also speed up the scope a little bit. Let's have it go a little faster. I'm moving at 1/4 degree per second. Let's move at 1/2 degree per second. All right. Now you'll see the telescope is more obviously moving, as you can see. Okay. So now, at this point where we are, all right. See, as soon as the moon goes away, you can actually see stuff. Okay. We're in a star field. All right. In fact, we can actually take ourselves up to here. Why not? And go check out this globular. And that's a good thing to, focus on too. Might as well do it when we have some no clouds, right? That's a good idea.
Sure.
Yeah.
Yeah, that's right next to the Caus Borealis there, you see. That's the top of the lid of the teapot.
Yeah.
And Nunki over there on the left, and Nimal Sadria, whatever it is, Sadria? Sadra. That's the top of the handle.
Mm-hmm.
And hey, you got M22, Great Sagittarius Cluster, just above that.
Yeah. It should be nearby. It's right there.
Yeah.
So we can go look at that, but I want to see if we can see this planetary nebula. So what we're going to do is we're going to take this now up to 5 seconds. So a 5-second exposure. That's one thing you're going to see. We're going to be doing shorter exposures than we used to. We used to do like 30-second exposures, minute exposures. I did an amazing job. Oh, look at that. That looks like the globular right there. I did a really nice shot of the Lagoon Nebula in 25 seconds. It was just beautiful. Some of you saw it.
Mm-hmm.
Why don't I preview that technology that I've got? I go in the tools here, and I say plate solve. All right, and what it's doing is it's looking at the stars, and it's looking at the pattern of the stars that you see on the screen here. And it's going to tell you exactly where the center of this field is. If you draw a line from the top left to the lower right, the top right to the lower left where they cross, that's the center of the field. And it's going to find exactly where it is. Now, it's going through several indexes. And it'll say did not solve, because it's looking in these particular indices, the index files. And it's local. It's on the computer out there. I set this up the other night. And so you'll see a green line at the top, and next thing you know, it should be solved. I have great faith in it. And it takes a couple seconds, about 35 seconds or so, because it's going through a lot of stuff. It's going through hundreds of thousands of entries. It's winging through them at very, very high speed. And if you put this same frame online, you go to astrometry.net. So astro and then metry.net. If you were to upload this photo, it would label this globular, it would label the stars too, for the brighter ones. Okay, this is the biggest index here, 4212, so it's going to take a while. Well, that's a really pretty globular down there. I think we're getting some clouds here, though. Sorry, I got this in the way. Got a little bit of clouds here too. Shouldn't make a difference though. Now it's in 4207. And what those are those separate files, index files, that actually it looks through to find where this location is. And it doesn't matter if the telescope is aligned or not, actually. Right now the telescope thinks it's at this position. We give the positions as like an extension of our latitude and longitude. Latitude being the horizontal lines that, go up as circles, and the longitude are like the lines of the beach ball from top to bottom that go around the planet. And we have 24 hours of right ascension. Those are the longitude lines, and the latitude lines of the Earth extended out into space are what we call declination. Why didn't we just say space lat and space longe? I don't know. That would have been very much simpler, but that's what they are. And of course, because the Earth rotates once in approximately 24 hours, just a little bit less, we have 24 hours in right ascension. All right. So that's how that works.
23 hours, 56 minutes.
That's exactly right. Almost exactly right. They'll argue that there's 56 point something.
Yes.
So it's still solving, but we don't need to wait for it. I would wait for it if we're doing research and stuff. What I'm going to do now is I'm going to actually increase the exposure. I'm going to go to 10 seconds. Now, we're actually relatively nearby the moon. So that's why we're getting this blue glow. All right. And I don't know if I'm messing it up by doing exposures back to back like this while doing this solve. Yeah, okay, see, it's still a little too bright.
I would wonder if, with the field so bright with the moonlight, if that doesn't interfere with it.
As long as you can see the stars, it shouldn't interfere with it. I really think it's probably gonna finish correctly. Just might take longer. Of course, I'm giving it a problem here by doing what I'm doing. The other thing too is I can adjust the settings here. I can actually take it and say, well, let's bring down. I can say let's bring down some of the blues or some of the colors here. Make it just a little bit easier. And I'm still waiting for Starlink out there. Once we get Starlink, that's going to change a lot of things.
Is Starlink one of those don't call us, we'll call you things?
Unfortunately, it is. But, they got, millions, literally millions of people that are clamoring for it.
Oh, yeah.
So reduce the blue curve there. Alright, I'm going to just cancel this because it's taking too long. Yeah, that's because I canceled it. Okay, so let's go see where we're looking at. Where are we looking, Captain? I tell ya. Alright, so I'll move this up. Okay. And let's head up to that, shall we? Up to the Sagittarius cluster. Then, of course, you look at the stars; they look pretty focused right now. All right, let's head north. Oops, that's a little too much north. Alright, let's drop it down. Okay, a little more. Alright, we should be in here now. There it is. Ah, that's one of your favorite clusters, Daryl.
It is. M22, Messier 22.
That's right.
It's not as big and bold as M13 or anything, but it's still one of my favorites.
Yep. And after all the discussion, I'm not sure Omega Centauri is going to be something we can see. I'm hoping it is.
I'm sorry, say that again?
After all the discussion, I am not sure that Omega Centauri will be one that we can actually see. I may have to raise the scope by several inches again.
Yeah.
To gain back what was lost during construction.
Right.
Alright, let's just drop this west now a little bit.
Probably kind of late in the season to try to see it now anyway. But next year.
Mm-hmm. That's right.
Or maybe... Oh, I'd have to go look it up. If you were going to do your 3 o'clock in the morning thing, you could probably catch it late winter.
Yeah, I'm sure.
Yeah, I know the time I saw Omega Centauri, it was already west of the meridian, and that was on May the 10th.
Yeah.
But I did get a good look at it.
Okay. There's this one red star in M22, which is really pretty. Let me come up here now and
Mark, would you excuse me for a moment, please?
Sure, you're excused.
I'll be right back.
All right. I'm going to try a little extra focusing here. That actually looks pretty good. Okay, I'll leave it for that for now. So as I mentioned, the collimation is off a little bit, and I have to recollimate when I go out there. Hey, Roni Hansen, how are you? Thanks for coming. Cindy Murphy, how's it going? Yeah, let's see if we can do a little processing on this. We may not. Well, that's kind of gives you a look. This is a 5 second. I'm going to drop the no, I'm going to drop the exposure by I'm going to increase the exposure, and it's going to get a little brighter. Okay, that's 10 seconds, that's too much. Drop it back. Once I have Starlink, this is going to be like I'm sitting in front of it. It's going to be just so fluid, and it's not yet. And it's like there's a 1 second delay on everything I do. It makes me crazy. But don't worry, I won't go nuts, I promise. Okay, this will be 7 seconds. Right. Interesting thing about these globular clusters is these are made up of very, very old stars, among the oldest stars in the universe, okay? So when we look at these clusters, okay, we see the stars in them, and we say, wow, there must be just a ton of life in these stars around in that cluster, because they have like 50,000 stars or more. And you say, well, there's got to be some stars that have life in there. And you know what? It's in these star clusters where we can probably say with pretty good certainty that we probably won't see life. And the reason is because of the fact that these clusters, unfortunately, have some of the oldest stars in the universe, right? But it means that they were around before there were a lot of heavy elements generated by all the other stars that went supernova and blew their guts out into the universe. So, as much as we love these clusters, and as much as they're beautiful, the chances that they actually harbor life are actually quite slim, you know. So it's unfortunate. It's unfortunate, but they are beautiful, and they're called halo objects. You know, if the galaxy is here with the disk of the stars and the nucleus of the galaxy, and this is the spiral arms. The globular clusters orbit the galaxy like this. They kind of go around the outside, but they do plunge through the disk. You know, they plunge through the disk of the galaxy and then come up. And I'm convinced that as they do that, they shed stars, okay, that they had inside the cluster, and then gain stars, you know, that they take out of the disk. So that explains, I think, some of the oddities we see in some of these globular clusters where, you know, they're all the same age, and we see globular clusters that have, say, planetary nebulae in them. Well, globular clusters with planetary nebulae almost don't make sense, because the stars in the globular clusters are all around the same age. So if you saw just one planetary nebula, meaning the stars died, you should see tons of them, and we don't. There might be 6, you know, planetaries, 3 or 6 that are actually been identified. So that could have been a star that was acquired in its orbit around the galaxy. We've orbited the galaxy with the sun just over 19 times. 19 times. So where we were born, that's 19 revolutions ago, 19 mixing of all the stars as we go around. So there's a lot of potential there, you know. All right, I'm going to do something else now while we're here. I'm going to do what's called a live stack. Yeah, what it's going to do is it's going to stack. It's going to stack this image. All right. And we're only doing, how many seconds here did we say? 7? 7. I'm going to drop that down to 5. Okay, 5 seconds. Okay. All right. And I'm going to clear and do this all over again. So what's happening now is the photo is being taken every 5 seconds. And if you look over here on the left, frames stacked is 2. Okay, right there. Right? We've stacked 2 frames. Right? And that number tells you how many of these frames have been laid on top of each other. And the purpose of doing that is to actually get rid of the noise and make it easier to process later. So that's kind of a cool thing to do. And when we're done, hey Daryl's back.
Thank you.
And when we're done, we'll actually be able to process it. Now we've stacked 8, and I'm going to actually hit the processing button here to see if it'll give us something. Yeah, see? And then what we do is we can drop down some of the blue and try and retrieve the actual color of the night sky that we'd see if we didn't have the moon. So you see, this is helping us out here. Alright. And let me try this. This might do the opposite of what I want. Ah, there we go. Okay, so that's a little bit more like it. A little too much orange, but I can pull that down right here. Okay, so that's on the border. But there you go. That's the images it would look without the moon. Okay, and so it's going to continue to stack. I'm going to pin that, which means it's down here in the lower left. See, it says live stack down here. All I have to do is hover over it, and it will come up, and we're going to see it. And I can also adjust the stack by looking at these values here, and I can move it, okay, if it'll let me, because it has to, it's just it's because it's not Starlink, because it's taking a second every time I touch it. By the time I click, it's not doing what I want. There we go. We can go backwards too. And make it really bright if we want. It's really curve adjustment. We're adjusting the curves here. This is beautiful. This is a beautiful, beautiful little globular cluster. You know, and we'll try to. Let's see if this is. Let's see if we can adjust the color balance from this. Okay, we got a little much too much green. Pop it down. So yeah, pretty cool.
Pretty.
Yeah.
I suppose globular cluster stars should look kind of yellow anyway.
Yeah. They're older. They don't have and anything. You know, we talk about globular clusters as having metals in their star spectra, but in the astronomy world, when we talk about metals in a star's spectra, we're actually talking about anything higher in the periodic table than helium. Okay, yes, krypton's a gas. Okay, but you know, it's not hydrogen and it's not helium. So hydrogen and helium are the base constituents of the universe. Okay, all hydrogen mostly, and then some helium. All right, and it's from nuclear fusion, which is called officially it's called nucleosynthesis. Nucleosynthesis is the reason we have all these additional materials in our periodic table. Okay, and that's pretty cool. Lucky for us too. Let me just check what we got for a sky here. Not sure if we'll connect. Okay. Now look at that. We still have clouds. And south is to this side. Moving to the left. Okay, that's where south is over there. So we actually, you can probably hear the sound too. It's got a microphone built in as well. You can see some stars up there. Yeah. Well, yeah, look, you know what? It's not a very good night. Spider web. It's not a very good night for all this because of the nature of the clouds. But you know what? It's not bad. I feel like we did okay. Okay, so now, okay, there's the observatory out there. And the roof is off, of course. And there we go. So I love it. Really pretty. Okay. Now, when I was telling you about the collimation error, let me show you what has to be corrected. Let's go up to 200%. Okay. And look at the shape of the stars. Okay. See the shape? It'll almost look like a fan shape. That's because the optics are not quite aligned with each other. And I have to align them. And while I'm here, I'm going to try and, first of all, this won't affect the stack, by the way. This is just a visual thing. Before I do that, I'm going to do auto here. Oops, auto. Alright. And then, I'm going to bring this up. And we go back to the stack. And I'm going to, I'll just save the stack. Why not? Sure. Okay. And it was 73 frames stacked, so that means that the images are going to have very little noise. And all that in just a few seconds. And then I'm going to save it exactly as seen. And then I can monkey with that too. Alright, so then we're going to pause the stack. Clear the stack. Alright, and go out and end the stacking process for this. And then we go in and take care of going down to 1 second. And now you'll just see almost nothing. Okay. So that's the 1 second shot right there. Alright. Now I'm going to come back here and I'm going to zoom way in on a star image. Let's go to... Well, first of all, let's do this. Let's go and do tools. We're going to do some critical focusing here. Tools. Focus assistant. Okay. And then I'm going to move this over. Let's try that star right there.
So what this is going to do is, where we were talking about a so-called autofocus earlier,
Yes.
it is going to adjust the focus just to try to make those pixels as small as possible, correct?
That's correct. So if we can get the pixels as small as possible, then we're going to be able to have good focus. And actually, I probably should try to focus something a little bit closer to the center of the image. That's probably best. So, and you don't have to be zoomed in on it, by the way. So I'm going to pick... No, that's actually not so bad. Let's try that. So we don't really see this too clearly right now because it's so, it's actually not very visible to us because it's tiny. We're only doing a 1 second exposure. And I only increase it, to a larger image just because it's just makes it easier. That's M22 right there, by the way.
Yeah.
So that's what we'll use. And while it's there... Oh, I hate the delay. Sorry, guys. I just hate that delay. Alright. Okay. And now let's actually start the focus process. Let's go back. Okay. Yeah, so we want those bars to come down. That's the wrong way.
Wahoo.
What?
Oh, old joke, never mind.
Oh. Alright, this is getting a little better.
So is it making adjustments on its own, or are you doing it?
I'm doing it right now. You know, there is you can have it do it, but I don't find that it's as reliable. It seems to me, but it could be. I just don't.
Can you explain what's going on in the bar graph down at the bottom?
Yeah, that's just those should be in the green. This is the relative focus based on the setting, which you can see there. 49,845 is where we are now, so it just puts that in here. You know, it's 49,845. And on the right, the setting now is, in terms of the size of the image, is 21.2, 21.184. The best was 20.6 before, plus or minus 0.5. So we're within the margin, but now we're trying to get a little bit closer. Yeah, and we want to try and get those down. I don't know why those are not going down though. I mean, it's a collimation error too. That's probably what it's causing a problem.
Yeah.
But I'm actually gonna leave it at this for a minute, and then come back to M22, because I think that because of the collimation error, the focus is being thrown off, the focus assistance being thrown off. But I think this might be better focus, but I gotta see. I'm gonna actually try a little higher exposure here. We're gonna go to an exposure of 4 seconds. Of course, it'll be a lot brighter. Yeah, hard to tell. I still see artifacts from the, obviously, the thing not being collimated. Yeah. But we will get it. Once it's collimated, it's going to be beautiful.
Well, that looked a little better.
Well, that's only because you didn't see that weird ring around it. But this is actually more out of focus, actually. If you look at the star to the right over here, you see it has a little hole in the middle of it.
I see that.
So I'm trying to get rid of that. This is what happens, folks. You know, you try to get these things worked out. Right, the star is too bright. How about this one? Actually, no, see that? I chose a better star, and now we're down in the green. So I think that's pretty good.
Oh, I see.
Yep.
Dimmer star, paints less pixels.
Well, a dimmer star doesn't cause any error in the focusing routine. You need a dimmer star for doing the focus. Bright star, you can lose in the glare of the star. You can actually lose some things, you know.
Yeah.
Pete, I'm actually not sure how long we're going to go, because there's a lot more to show you, but I don't know if I'm going to get a chance to do that. We'll see. Okay, we're done with that focus.
Check in when you get home.
Yeah.
Drive safe, or however you get home.
Oh yeah, Avi Loeb's Galileo project. Thank you for mentioning that, OG. Yeah, actually, I haven't talked to Avi about it myself yet, but I have talked to him a number of times, and he's the Galileo project is an interesting scientific approach, and I think he's part of this project because he was sort of marginalized by daring to say there might be life elsewhere that made it here. And if you think about it, what scientist in his right mind would say that the prospect of life being elsewhere in the universe is nil? That's not true, and most of academia doesn't say that now. They agree life elsewhere is probably a foregone conclusion. What the problem is, though, is they don't say that they're here. They don't admit that they don't even suspect that they could be here. And I get that. It's really a very big problem getting here from there. No doubt. But I do know that there's going to be a lot of further research on this, and you're going to probably find that a lot of people are going to fall into the camp where they say, this is something that I think is possible and probable. And the reason is because they're going to feel that, hey, there is plenty of opportunity and options for an advanced civilization to utilize some really interesting technologies in order to do this and get across the galaxy or across in between star systems. There's no reason that can't happen. It is. Huh?
I'm sorry. Go ahead.
I'm saying it's a daunting prospect for sure. I get it.
He came to the public attention with his remarks about Oumuamua, didn't he?
Yes, he did. Yeah. I've talked to him about that, and you know what? We're actually of the same mind on it. It's actually shaped like a pancake. People thought it was long and thin, but that's because it was on edge. It's like this, okay? So your phone on edge looks like this, but it really is flat. And as it was rotating, as it came through, they saw this change. As its aspect ratio changed, as the amount of thickness presented to the camera changed, then it caused it to get brighter and dimmer. But see, that's not what made him think that it was a solar sail from a distant culture. What made him think that it was possibly and couldn't be excused, okay, was the fact that as it left the solar system, when it went out on that hyperbolic trajectory, it actually went out very, very fast. In fact, it went faster than it should have, and that was the weird thing. It didn't move at a speed that made sense. It should have gone a lot slower, when it left, but it didn't. It actually made movements on its way out on its path that seemed to be directed. Now, is it possible that it was a actual solar probe? Yeah, I mean, it could be. You can't deny the possibility, and that's all he was saying. He wasn't saying it was aliens. He was saying you can't deny that it could have been a solar probe. That's all he was saying.
Yeah.
I'm going to talk to him again, actually, because we're gonna talk about the Galileo project. I think I'm in the nebula here. Let me. Yeah, so I got a. It's a huge frame. This is a giant camera. It's got a lot of pixels. Oh, looks like we got moonlight. Moonlight. That is a problem. Yeah. Alright. We're down here. And the moon is just below us. So that's where the moon is, and that's where we're trying to go. So that isn't going to really work. Let's see if we can go to the Trifid Nebula as well. Let's just go there. A little west and a little north. Okay, that's too much west. But I can drop us down. And that might not be good either, but we'll find out. Okay. Every little bit we move north, it's going to get dimmer. See, that's the lagoon right there. Alright. Let's see where we are. Oh yeah, we definitely have that moonlight on the right. Moonlight Sonata. Yeah. You know, of all the nights to stream, I picked a night where the moon was in the Milky Way. You know, so what can I tell you?
What are you gonna do?
I know. That's all right. I think people are enjoying watching and seeing what's happening. I should just probably go back to the moon. You know? But let's see if I can go further north enough. We could try that. Okay, let's try that. Okay.
Small Sagittarius star cloud?
No, the star clouds won't work well tonight with the moon. They're going to be all blown out because they're just, the sky is too good out there. So what I'm going to do is I'm going to race a little bit to the east. And race some to the north. Yep. Okay, here we go. And raced more to the east. Back up so I can see where I actually am. That's right. That's where I want to be. And let's go more to the east. If you're wondering why I'm not just doing a go-to, I am going to be doing go-tos again. But I'm not doing them right this second. Okay.
I heard Avi Loeb talk about xenoarchaeology somewhere the other day.
Okay.
Might have been a program, a KJRA program Bill played or something,
Okay.
when he was doing his Perseid watches. Xenoarchaeology sounds great, but I mean, don't have anything to look at yet, do we?
No, we don't. We do not. There it is.
Going for Omega?
I am. And there it is.
Mm-hmm.
Yep. And that's a 4-second exposure. That's why it's taking so darn long. All right. Usually I set it to like 1 second, and then you can actually see it update like right away. But this screen's a little dimmer, as you'll see. But you can still see it. All right, and now we head to the west a little bit. Yep. There we go. Okay, now I'll just do one more little jog. Okay, now what I'm going to do is this. I'm going to let that settle out and change the exposure. Let's say 8 seconds, and let's see if that's going to be too bright for tonight. It might be too bright for tonight, we don't know. Maybe a little bit too bright. But, you know what we'll do? We're going to do a live stack on this anyway. Let's have some fun. And we're going to clear and let it start over. And we're going to do 8 seconds. And as you can see, we have this beautiful nebula showing up. Okay.
Also known as the Checkmark Nebula, or the Swan Nebula, or as I like to call it, the Duck Decoy Nebula.
Yeah.
I think what I see as the Duck Decoy is what the Swan is supposed to be.
Oh, the upside down duck?
Yeah.
Okay. Okay, so as we're stacking, then all the noise on the image gets less and less, and it actually gets better. We've stacked 5 images so far. And I can come over here and grab down here. I can grab these bars and move them around to try and look at the difference in how the processing will affect the image. So you can see now we can actually bring out more detail by doing that. If we do this, we'll blow it out, you know, and you really want something kind of in between. So this one over here is your black level, this one is your middle level, and this is your white level. You know, you can make it look gray and washed out if you move this, you know, over too far. So let's see, this guy is probably not what we want. Yeah, it is. It'll work. Okay. Alright. And this will be a little bright. Yeah, see, too bright. But you get to see some additional stuff. Even with the moon out, you see the rest of this nebula. That's really kind of cool.
Mm-hmm.
Very cool. Okay, so we'll just undo that bit of it. And go back to our stack. Okay, we've stacked 16 images so far. See, that's what I like about this, guys. You don't have to wait for the stacks anymore. Because I'm going to save them, and you're going to have the stacks. By the way, for those that actually saved the address that I shipped out to you in the post, and you all have access to it, you can go up and see all these images just as they are now, because they'll be up there in about, I don't know, say 30 or 45 seconds. So they're being shipped up to the cloud as we speak. The stack, as soon as I save it, like when I say pause, okay, stack pause, when I hit save, you'll see a green bar up here saying it's been saved, and it's on its way up now, heading to the cloud. Let me try doing a plate solve on this location. Identify the exact center of our frame. Had I let that other one go before, it would have gone. It would have made it. The other night when I was doing the plate solves on this, I tested it out. The sky was a lot darker, so the brightness of the sky could be causing some double checking that the software is doing. That could be causing issues, but it works great. I mean, Daryl and I did it earlier. He saw that it solved a location that was just stars, blank stars. They figured
did it
out
in just a few seconds too.
Yeah, that's right. Yeah. So I'm not sure why it took longer, or why it's taking longer now. But
can you think offhand of visual astronomers who would sort of like do or be the equivalent of plate solving or plate solvers?
I think we were talking about, if I recall, there was a whole crew of women that were doing this. Some of them were at Harvard, I believe. And I think that Annie Jump Cannon was one of the people on that team.
They're the women they called computers, right?
Might be true, yes.
I was thinking more like dedicated amateurs.
Oh, you're not talking about like the women who actually had to get it right for the journals and for the catalogs and the atlases?
No, I was thinking like if you showed a random star field to somebody, who might be most likely to recognize it?
Okay.
I would guess comet hunters.
That might be true. But,
you know, the real dedicated comet hunters, they're out there every clear night looking, and they roam the sky every night.
They do.
Over and over and over as the days turn to weeks and the weeks to months and the months to years. And those people literally know the sky like the back of their hand.
That's right. They do.
They could look at a given star field, and if they see something that looks different, hey, there's a fair chance they found a comet, you know?
Yeah. Alright, let's just save the stack again. And then save it as...
suggestion, stop.
What?
It's been saying live stacking is paused up at the top for a while.
Yeah, I know.
Oh, okay.
Yeah, I know. I realized I only did 21 frames here.
Alright.
So I wanted to get that out of the way, and then I can stop the stack.
Very good.
Because I think it might have interfered with our plate solving message that said it had solved the plate.
Oh.
Because that's where it goes. So I'll have to figure that out. Alright, let's do plate solving.
Excuse me.
Alright, let's see what we get. I'm waiting for the green message across the top. It's not gonna solve everything from the same index files. It has to go. Ah, there we go. So it succeeded. So we copy, and what that means, what's happened is, it actually solved for our center of this very field. So this is where it said we were. Right ascension 1821.31, and we're at 1820.22. Okay, and declination is 1620.31, 16 degrees 20 minutes 31 seconds south, and so we're at 1601. So we are very close to where the plate solver determined. Now what I can do if I wanted to is I can take these coordinates right now and put them in to this program over here and then say sync, and the telescope will then say, oh, okay, now the center of the field is exactly where this program also says it is. It'll align the telescope effectively, but we're aligned right now enough. All right, so that is how that works. It's really quite amazing. You just want to play with it. You just want to like go plate solve stuff. Crazy, I know. Welcome back, Daryl. The plate solve worked. I don't know if you saw that. It took just a few seconds, and it did solve it. You hear me?
Stand by.
Okay. All right, let's.
It dropped out for a minute. I can hear you now.
Okay.
And I got that poor connection note on Skype when it dropped out.
Okay. Hey, David Schmidt.
I hear you okay now.
How you doing, David Schmidt?
It's lunchtime in Thailand.
That's right. Okay, and right now we should see another beautiful nebula. And again, we're doing this all with the moon out. Yeah. There it is, right there. Let's move that sucker over, shall we? This image we're going to take is of the pillars of creation. We've taken it before on the night when there's no moon, but we'll take it again tonight and we'll stack it and see how it looks tonight. I always like going up against the these algorithms, you know. It's kind of fun. It's actually a lot of fun. And we'll do 8 seconds, and let's do a live stack. Actually, we'll do 9 seconds. 9 seconds. There we go. This is going to be so much better when we actually have the Starlink. I don't want to keep complaining about it. Okay. We're covered there. And now let's do stack. And we're going to clear this. That was the previous one. And now we're stacking all over again. So 9 seconds. There it is. 9 seconds. We're going 9 seconds. Our gain is 350, basically like the ISO. And that's really pretty. And we can put this over here. Look at that. Isn't that pretty? We can actually also zoom in a little bit on that if we say 25%. Oops, wrong way, sorry. Let's go 40%, I think, is what I've been using. Actually, I did 33. I'll do 40. There we go. All right. You can see the pillars of creation there, even with the moon out. And let's bring up the live stack again. And let's do a quick process. There we go. Well, that's cool. This might be too much. It's okay. But you can see the pillars of creation in there. I can see that I definitely, when I look at things like this, I just realize I can do so much better if we collimate this telescope. And I can't do that from here. I literally have to go out there to turn little tiny knobs. You know, I might be able to get Marianne or Tara to do it, though. I can instruct them how to do it. But they'd have to be out there at night, and I don't want anybody out there at night. It's, there's wildlife out there. Okay, let's see how many we've stacked. 16 so far. And let's take this. Okay, and let's try and play with this. I want to change this mid-level here, but here we go. It almost let me grab it. So I asked before how many people actually did get to watch the Alien Invasion Hudson Valley show on Discovery Plus.
I don't get Discovery Plus.
Well, that's, I don't get any television either. I saw it because they sent me a copy of it, but I didn't.
Oh.
That's the only way I got to see it. I didn't have a viewing party or anything like that because I don't do things like that. It just was. It was an investigation where we actually, I think, did it in a way that's very different from other shows. So I don't know if that makes any sense. Yes, you want your Jetsons flying car.
Hey, it's the future, damn it.
I know.
I'll take it that bleeble bleeble and all. You know the sound it makes?
Yeah. It's like... does that noise. I cut my lip so I can't do that too well right now tonight. But boy, that's kind of what it is, Wow, thanks again. Leslie, I didn't realize you watched it 3 times. Holy cow. And Cindy, that's cool. Well, thank you guys. That's really nice. It'll be out there for a while. I got to do a lot of press things on Friday. And I got to do more on Tuesday. Because it's streaming, you can watch it anytime. It's up there. Like Netflix puts stuff up there. You can watch it. Look at this nebula coming out up here. Look at that. That is really nice. On a moonlit night, it's spectacular.
Hmm.
Yeah. Let's see if this does anything or hurts us. Kind of hurts us. Let's undo this. See, that's what it looks like without the processing. Okay. So that's why processing is really so important. Yeah. That's pretty. Did you mute?
Stars are kind of yellow.
Yeah, I know. Did you mute yourself?
Hello?
Did you put yourself on mute before?
Yes, I did,
Okay.
actually.
Just making sure. Yeah, stars are a little bit yellow, and I can fix that in the live stack. So we're going to take down some of the red. Might actually be able to do it by doing this. Oh, well, kind of, but not really. I didn't think I was going to be able to stream for long tonight, if at all, because of the nature of what the sky was out there, the clouds. But luckily, we're okay. Yeah, that's another thing too. Because of fires in the country, we're probably going to have a little bit of extra yellowing to our stars as well. That's not why these stars were that color, but it's possible that that's going to cause problems.
As I said in chat, I was watching it earlier today. Checked it when I got up this morning, and on Windy. And you could see the low pressure cell coming, or whatever it is, was kind of pushing it up more toward the north.
Yeah.
Today, it looked like Wyoming was getting it really bad.
Yeah. Dave Schmidt, there's still some intermittent issues out there that I'm trying to work out with the telescope system. Luckily, I'll be out there in a few weeks, and I'll be able to actually fix further issues. And the last thing is I've got to get the stars to be pinpoints. They're slightly elongated, and that's because of the fact that there's a lens at the top and then there's a mirror at the bottom, and they're just slightly out of alignment with each other. I've got to square those right up. And that's called collimation, and then the images will be round. Right now they're a little bit teardrop shaped. And that's not good.
I hate collimation.
You and everybody else. Okay.
When I still worked on lasers, we had one make of laser that had 7 optical elements in the light path.
And those all had to be
talk
collimated in order.
Painstaking.
Yes. Was it an iterative procedure? And for those listening, that means having to go back over and over to the previous ones you did to match them up again to the new setup that you have with the further collimated, and aligned mirrors or lenses rather.
Like refining it, you mean?
Yeah. Did you have to iterate through it?
Yes.
So, let's say there's 7. You take care of aligning 1, 2, and 3 with each other. You go to align 4, and you align 4, but you realize that makes the stack of 1, 2, and 3 now out with each other, and you've got to like realign them to each other, which takes 4 back out, and you got to kind of keep going back and forth. That kind of thing.
Yeah. You could say that, I guess. It basically, you start the optical alignment with the optic closest to the laser.
Yeah.
Once you think you've got it, then you start moving to the next mirror or lens farther out.
Okay. Gotcha.
And yes, you will often have to go back and refine your earlier settings.
Yeah.
Then after you get the last one set, then you've got to go back to the first one, and there's a red pointer beam. You want to get it aligned with where the laser is hitting.
Yeah.
And sometimes you wind up moving stuff all over again.
Yeah. I understand that process like you can't believe.
Yeah.
Oh yeah. Well, that was the Eagle Nebula, guys. And unfortunately, until the moon gets out of the Milky Way, which will be by tomorrow or the next day, we're not going to be able to really image anything too well down here. But that's okay. We can image globular clusters and things like that. But I think that we should do one more object. Just one more. Don't you think?
Go for it. Now, I warned the powers that be at work for years, you're going to miss me when I'm gone. And they'd just laugh and, roll their eyes.
Yeah.
When I retired, well, it wasn't 3 months and I was getting phone calls from them wanting me to come back.
Yeah. Well, hey, I think that's you proved your value.
I guess. I worked with a bunch of hammer jockeys, and some of them just had no finesse at anything. And if there's anything that requires finesse, it's dialing in, collimating laser optics.
Yeah, for sure. Okay, this is 40%. What I gotta do is go to auto so we can actually see it. There we go. Alright, this is that little cluster that I was just looking at in here. NGC 6604. And when we're up in there,
oh, what's that at the bottom?
we were just there. That's the Eagle.
Oh.
We actually took a picture just like that when the moon wasn't out. The pictures we take are better than in this planetarium program, actually, which is really cool. Yeah. So this cluster here that we're looking at, it has less than 50 stars, but it's actually a little cutie. It's really cute, you know? So let's see if we can do something with this. Yeah. And then if I bring up the live stack, I can actually, even though I'm not doing it, if I clear, and let it do its thing. Look at these beautiful stars over here. It's really pretty.
Uh-huh.
Well, guys, you know, so I think it's kind of cool. I'm glad that you guys could come along tonight. I realize that, you know, it's not the same as being where there's no moon out, but we can still check out star fields and look at these things. These are really, really pretty locations. You know, yeah, we can. You know, I could do. Since we're in here, I'll do this too from now on. I can actually just maximize the size up there. You know what I really like? This is cool. You see this a lot. Not that. Okay, that's not what I was saying I like so much. But if you look, okay, right. Let's see, is it there? Or is it down there? Yeah. Okay. Right here. Okay, see those two stars? Look how red they are. Okay, and then some of that is an artifact of their distance. Some of that's an artifact of the night. Some of that's an artifact of the smoke. But when we, you know, another one's like, you know, right here. You know, there's another red star right here, really tiny one, and one just above there. When I was doing this, when I was doing astronomy, doing photometry, which is where you take the light of a star and you do what's called an integration. You actually build up the light of the star. And the reason was to get the actual brightness. You had to do a whole bunch of things to get the actual brightness of the star. You had to calculate how much air you were looking through and subtract out, you know, or add back in the amount of brightness lost because of the air. And that's called air mass calculation. You had to calculate for the angle above the horizon and calculate atmospheric extinction, okay? And then you had to calculate the actual extinction based on the distance to the star cluster in interstellar space. So a distant star cluster will look like this, okay? You'll have a bunch of stars that are very small. Now the size of the image object, just that doesn't mean anything, okay? This star, the brightest star in this field, could be right next to these guys in space. But in general, when you have a cluster where you have many small stars, it means that they're dim. Their light is subject to extinction, interstellar extinction, dimming the further away they go. Because if you watched SkyTour Radio the other night, when Daryl and I were talking about dark clouds in the Milky Way, we call them dust bunnies in the galaxy. You saw that those dust clouds tended to make the light from the stars much dimmer because it was blocking some of the light because they were in front of the stars. But the stars shone through, But the extinction process, that is what those little tiny dust grains do, is they redden the light of the star, making them look redder. And sure enough, when you look in some star clouds, you see these beautiful stars that are white basically, but then they start to get yellowy. And that's a clue that something's in front of them that's causing their light to get reddened. In the same way that the air, the additional air over the curve of the earth that the sun is showing through at sunset, causes the sun to be redder. Okay? And it's because of the way the air is working on the spectrum of the sun. It's actually taking the blue light and scattering it in all directions. And when there's more air that we're going through, then the sun's going to be redder. If the Earth's atmosphere was twice as thick as it is, okay, our sun would not be whitish yellow in the sky. It would be kind of yellowish red. Yellowish orange, I should say. But that's because of what happens. And sunsets would just be a blaze of just a very, very crimson red sun. It would be stunning. Yeah. Wow. Okay, I'm off my high horse. Alright, so now what I'm going to do is, I think I have a live stack going here, don't I? Or did I not? I must have. Yeah, okay. So we're going to pause it and save. Okay, and then we're going to save it just as it is. And then I can modify it in addition. Alright. Good. Alright, and now what I'm going to do is I'm going to solve for this exact location again. This is another way to find out exactly where you're looking if you're not quite sure. So this is going to actually probably be pretty quick. So guys, this is the last object tonight. I figured an hour and a half, and we into an hour and 50 minutes, so not bad. I am cautiously optimistic that the telescope is operating properly. We did have a snafu with it, which meant that one night we had the roof open with the telescope pointing right up in the sky, and we couldn't access the telescope until the following morning. Luckily there was no rain that came through, but in the desert that's something we don't really have to worry about so much. But it was pretty nerve-wracking waiting for the morning and getting someone out there. But I hope you guys had a good time tonight. And look, we got our solve there. We plate solved. So I'm going to copy that down and put that into our file here and use that to show me exactly where we are. Yeah, very nice. Okay. So I will be back on the next clear night, I hope. And this system's running a lot better than it was before. So we're having a good time. Thank you guys for your patronage, and I hope you enjoy the nightly forays that we go off into. I know you enjoy Daryl. I know you enjoy Amanda. Amanda hasn't been around because she's been very busy. But we haven't forgotten her. Hey, Vera Lucia. It's good to see you. And I think that we will do much better once we actually get to the point where I have the telescope perfectly collimated. That's a very important thing. Extremely important. Alright? So, you guys have a good night, and we will talk again on our next clear night. Daryl, thank you for coming.
Sure, thanks for having me.
Of course. You're just, you're wonderful. I always call you an astronomer's astronomer. Like it or not, that's who you are.
I'm a regular Cliff Clavin, like I usually say.
Yeah, you know, the normie.
Yeah.
That guy.
Good night, everybody.
You guys have a good night, all right? We'll see you later. Thanks for coming. Hey, Leslie, thank you. That was very kind. I had to come back on to say thank you for that donation. That's wonderful. You made my night. Thank you so much. Have a good night, everybody.